Hello and welcome to yet another South Korean college scholastic ability test video. Today we are going to solve the following problem. The figure shows the graph of function fx, which is an absolute value of 5xx plus 2 when x is negative, and absolute value of 5xx minus 2 when x is positive or 0. How many distinct real roots does the radical equation square root of 4 minus fx equals 1 minus x have? Alright, so the first thing we have to do is to square both sides to remove the radical. Then we have 4 minus fx equals 1 minus x squared. So we have minus x minus 1 squared plus 4 equals fx. We only have to find the number of distinct real roots, not the exact values of the roots themselves. And the number of real roots to this equation is the number of intersection points of two graphs y equals minus x minus 1 squared plus 4 and y equals fx. Here, this minus x minus 1 squared plus 4 is a concave parabola with point 1, 4 as its vertex. And we can easily sketch this parabola. So this 1, 4 is the vertex. And you can easily find that when x equals 2, y equals 3, and when x equals 3, y equals 0, and so on. And on the left side of the axis, when x equals 0, y equals 3, and when x equals minus 1, y equals 0, and so on. So in the end, we have this parabola. And if we count the number of intersection points between the blue parabola and the graph of fx, there are 1, 2, 3, and 4 intersection points. So these alpha, beta, gamma, and delta must be the real roots of the given radical equation, which means that the number of distinct real roots is 4, right? Well, not really. You see, when you're dealing with real roots of radical equations, you must always be aware of the hidden conditions. Consider finding the real roots of the radical equation in square root of fx equals gx form. Here we have two hidden conditions. First, the inside of the radical, fx, must be non-negative, because when fx becomes negative, the left-hand side becomes the imaginary number. Second, the square root of a non-negative real number is also non-negative. So the entire left-hand side is non-negative, which means that the right-hand side also must be non-negative. So we have the condition gx is greater than or equal to 0. So from our given radical equation, we have conditions 4 minus fx is greater than or equal to 0, and 1 minus x is also greater than or equal to 0. Therefore, we have fx is less than or equal to 4, and x is less than or equal to 1. Here, f alpha, f beta, f gamma, and f delta are all less than 4, so they all satisfy the first condition. However, gamma and delta are greater than 1, so they do not satisfy the second condition. Only alpha and beta satisfy the second condition, meaning that only alpha and beta can be roots of the given radical equation. The reason why we obtain extraneous roots such as x equals gamma and delta is because we have squared both sides to solve the given equation. Here, the reverse process is not always true. More precisely, the correct logic for the reverse process is that 1 minus x can be either square root of 4 minus fx or minus square root of 4 minus fx. And gamma and delta are values that satisfy this alternate equation with opposite sign. Therefore, they do not satisfy the original version of the radical equation, but they do satisfy the squared equation. Therefore, like I said before, the only valid roots are x equals alpha and beta, so the given radical equation has two distinct real roots. And that was all for today's video. If you want extremely challenging problem that also involves the radical but also combined with calculus, please go check out this problem from the CSAT of the same year. Thank you all for watching, and I will see you in another video.